Hey everyone, have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Hi everyone. Okay, so the last video we talked about a lot of different things. We talked about encrypting and decrypting the numbers using some modulo arithmetic to be able to move these numbers around to replicate what we've done with our cipher. So we have an operation that we want to perform on the numbers, this perform sum operation, and we have a way of translating letters to numbers and numbers to letters with our functions that we made with the dictionaries. So the final thing to do is just put all this together. So let's describe, again, maybe in a little bit nicer writing, what we're going to do. So we're describing an algorithm. Algorithm for encrypting letter. So we're going to first translate letter to number, right? Second, we're going to perform encrypt number on number from step 1. And then 3, we're going to translate number from step 2 to letter, right? So we're going to translate a letter to a number, perform some operation. In this case, it's going to be this encrypt number on it. And we're going to translate back to the letters from there. And that's going to be our encrypted jumbled up letter. Okay, so this is our algorithm. Let's try it out. First thing we're going to do is we're going to say number is equal to translate letter to number. And we're going to do this for, let's do it for the letter H, right? Because that's what we were working with first. And remember, we got this EF, and the actual final value we got was this EF thing. So let's do it for the first letter. And once we've done it for that, as I mentioned before, we can do it for the entire string like we did before. But we're looking for E is the result we're trying to get, right? So we translate our H to a number. We're going to perform encrypt number on that number. So new encrypted number is going to be encrypt number, right? So this is going to be the shift. And because we don't pass an argument, it's going to use the default argument, which is 23. And then we're going to say encrypted letter is going to translate number to letter encrypted number. And then that's gonna, so this is, encrypted number. Okay, so this is the 3 steps basically, right? We have our number, we have our letter, which is H. So let's actually just make this a little bit more general. We're gonna say letter is equal to H. We're gonna pass this in as a variable instead. So we have our letter is H. We're gonna translate that letter to a number. And then we'll have this number, and we'll store it in this variable number. Then we're going to encrypt the number using this logic we talked about in the last video, which has to do with modulo arithmetic, which is going to move, in this case, it's going to do this left shift of 3. It's going to move whatever the number is, back 3 in this kind of big loop, right? And then we're going to translate that number back into a letter to get our encrypted letter. So that's going to be the general approach. What we're looking for is E. We should see that this will return E. And let's print out this encrypted letter, and we get that. We get our E. So this is the general idea, right? So now we have an algorithm for determining what our letter is going to be. Instead of using a letter to a letter, like how we had here, encrypt letter, and we just took each individual letter and translated it, now we have a little bit of a more general framework. Now you might ask, we just did a lot of work to produce the same result. Why did we do this? First off, we can now do this with a lot of different variable types of ciphers, right? But first we had the right shift equal to 23. All I have to do now is change the right shift to 1, and this whole algorithm changes, right? I'm now encrypting it in a different way. So that's a nice thing about it. Secondly, we now have a much more generalizable and abstract version of this, right? We can actually do anything with this number. We don't have to use this particular type of computation. As long as it's modulo 26, we could have done anything to this number and it would have been a valid encryption algorithm, right? So we've generalized everything to make it easier for us to use, right? Translating these letters to numbers and then doing something with them is much easier than doing a translation directly between letters. If we wanted to do this same exact translation in the old way, we would have had to define this for every single letter, right? This left shift of 1 or the shift of 1 would be A and then B and then C. And we'd have to do that for every single letter. So now we don't have to worry about that. Okay, what's the next step? So first thing we're going to do is actually just make another encrypt letter function. It's going to be composed of all what we just did. So the easiest way to do this is to first, let's define encrypt letter. And then we're going to have letter as the argument. And then we're just going to copy all of this over. So no need to rewrite the code that we just wrote, right? Because we use letter, we can just paste it in directly here. And we're going to just return that encrypted letter. So you can see this is much nicer looking than the original one. And we're using dictionaries, which is overall a better way of approaching this problem, right? It's less code and it's much more efficient. So everything about this is nicer, right? And what we're going to do here is we're going to also pass another argument. We're going to make this a optional argument, a default argument. We're going to call it right shift equals to 23. So again, we're going to have that right shift, and we're just going to pass this right shift in as a variable into this encrypt number function. So we're doing the same exact thing we just did here, right? We passed everything in. We're just going to put it into a function and clean it up a little bit so that we have now a factory that's just going to spit out encrypted letters when we pass them in. So when I do encrypt letter A, it gives me X, which is what we expect if we remember our original algorithm. But again, I can change it to a different cipher by just changing the right shift. If I want to do a right shift of 5, it's now F. So it's going to change everything about how I did this entire algorithm in a very simple way by just changing that one argument. Now I'm able to do what I would like. Now, to go back to the very first thing that we did, I'm going to use similar logic here. We're going to say encrypted. So this is just for a single character. We want to do this for the entire message, right? So encrypted message, we're going to set this equal to an empty string. Then we're going to say for character in message. So this is the original message. To look at the original message, let's just take a quick look. It looks like this. Okay. So for character in message.upper, we're going to encrypted message is equal to encrypted message plus encrypt letter character. And then we're going to print out the encrypted message. So what this is going to do, again, is we're going to start with an empty string. For every character in this message, we're going to first encrypt the letter, right? And then once we've done that, we're going to add that on to the end of that string. Now, the first time we did this, I made it a little bit easier by doing this. It's the same idea. I just made it a little bit cleaner and easier to read. We can do it this way too. First, store the value that we're encrypting in this variable encrypted letter, and then we're going to add on that encrypted letter to the end of this string, and it's going to just become a very long string, and we're going to print that out. So this is the general idea, and this should work. However, we're going to run into a similar problem we did the first time, except this time it's going to throw up an error at us. So let's take a look at that and see what happens. Okay, so we have a key error, and this all goes back to dictionaries. So if you remember before, I mentioned that in dictionaries, if a key isn't present in the dictionary, it's going to spit back a key error. In this case, we have a space. So this string is just a space inside of a string, and it's saying, I don't know what this stands for, right? Here's what we're going to want to do. We're going to want to change that inside of our dictionary so that it accommodates for this space. That's one way of approaching it. The other way of approaching it is by using exception handling. So what we're going to do is there's two ways that I can see that we can handle this problem. The first way is using logic that we already know. We're going to talk about that now to get to use this. And it has a little bit more to do with strings. So we're going to talk about in here. To give an example of, for characters and for lists, actually, you can use the keyword in to see if it's in a list of strings or in a list of characters or in a string of characters. And it will give you a Boolean value back. So we use the word in. To give you an example of what this is, C in dog will return false because the letter C is not in that string dog. But C in cat will return true because C is found in cat. And this actually works for lists and any group of these iterables, these collections as well. So if you said fun in dog cat as lists, it's going to return false because this string is not in this list of strings. But if I added fun to this list of strings, it will return true because it is. So this is something we can use in general to figure out if a certain character is in some list of values. In this case, the three values that we're considering for this specific use case is the comma, the space, which was not there, and the exclamation point. So those are three things that we want to look out for. I'm going to say if character in, and I'm going to make a string, and I'm going to say space, comma, exclamation point. So it's going to check over this like it's a list. So it's going to say if it's in any of these, what I want it to do is I want it to pass. Otherwise, I want it to run what I've run here. So basically, if it's in one of these values, I want it to just skip over that particular character. Otherwise, I want it to run the code that I had initially ran. So let's try this. And this works. But if you remember the first time, we ended up with this ugly looking thing, and we got the same exact ugly looking thing. That's because we're replacing these with empty strings, or in this case, we're not even adding anything to the string. Instead of doing this, what we're going to say is encrypted letter is equal to space. And instead of having the encrypted message over here, we're actually going to backspace the tab so that it's in the outer block, which means that this line of code will be run no matter what the if and else statement is. So before now, we've just been dealing with if statements that were dealing within a block. There hasn't been a lot of if and if then statements outside of that. We have it here, but maybe we might not have thought of it that way. But the indents really do matter, right? In this case, what we're saying is, if this happens, then just run this line of code. And if otherwise, run this line of code. And in both cases, we're going to run this no matter what. It's going to reach here no matter what. Now, if I added a tab here, it's only going to run this if it goes down this line, right? Else. It's not going to run it in the if case. In this case, the character is in that. So that's one thing that I wanted to talk about. But here, we want to run this in both cases, right? When it's in these three characters, we just want it to return a space. Otherwise, we want to perform this logic to encrypt the letter for us. Okay, it's a lot of work, but we now have our way of encrypting this message, and we end up with the same exact message we had before. We just took out any of the punctuation. But see, this is the same exact message. However, the nice thing about this is that we can now add our own right shifts and completely change the keys that we're using for this cipher. So if I change this to 5, I'm going to come up with a completely different string and a completely different message. Okay, so that's everything for that video. In the next video, we're going to talk about how we can handle this situation in a bit of a better way, because there is a better way to handle this. And after that, we're going to talk about decrypting the message to get back into its original form.